Hey, can somebody give me a com check? Check, check.
Yeah, I can hear you.
Okay, we'll see. I rebooted and moved my Wi-Fi extender. We'll see how it goes. So get started again here in another minute or so. Okay, y'all. I do apologize. That's frustrating. But what can you do? Okay, so back to what we'll cover in the next 4 months. Like I said, Excel as a more of a personal data analysis tool, chart creator, that sort of thing. More than there, you can do so much with Excel with macros, and you can turn it into an entire application. You might have seen. We used to do, if I had travel expenses when I was at UCA, the entire travel voucher form was a multi-page Excel worksheet, which was not optimal, but folks have been able to use that tool for so much. But we'll be doing mostly just uh, individual data wrangling and analysis. But I also want to move into relational databases like Oracle, MySQL, SQL Server. A little bit of foundational theory as to how those tables are put together and what makes a good relational database, and then we'll go over the syntax of the query language, the language that you use to interact primarily with that relational database. We'll go a little bit into data storytelling, dashboards, reporting, that sort of stuff, Power BI. I'll try to get someone with pretty good hands-on Tableau experience. Are any of you using Tableau by chance?
I have used Tableau. I'm currently in a master's program, and we've already kind of gone through all the tools.
Oh, okay, and that was you, right, Paul? I'm looking at
Yes.
the PowerPoint. Okay. Um, yeah, great. Yeah, there's seems to be somewhat of a, um, uh, a huge battle going on. Tableau software is owned by Salesforce. So there's that kind of that camp, and then there's a lot of folks in the Microsoft stack using Power BI, but there are so many others. I know the CAE folks, their primary visualization tools is a product called Domo. Um, last last time we did this course, about half the class was using Google Data Studio. So it's, yeah, and it seems to change year to year. And then one of the heavy emphasis I put on the course is learning to write code. And I don't assume some of you are already, computer science graduates, have all kinds of coding experience, and you're ahead of me. But I don't assume that anyone has coding experience. So I start from the very beginning, and I use Python, even though we've got some awareness of R. R is another programming language that is more embraced by the quote unquote real real data science statistician hardcore researcher community. I don't know that there's anything R will do that Python can't, because there's so many analytical libraries that you can import to do analysis. But R is definitely used more in college statistics courses, things like that, scientific courses. But Python is much more widely used and applied in different settings. Um, Python analysis is being used to comb through log files for cybersecurity. It can be a web development backend language. It can do what Java does in a web stack. all kinds of IT automation tasks. So Python is taking off on a much greater trajectory anyway than R. So because it's so much more broadly useful, that's why I go ahead and embrace that one. But I'll try and weave in some other advanced topics. Like I say, I bring in guest speakers so that you're not just listening to me the whole course. I've been an analyst, but I'm really more of an IT generalist. I've been a software engineer, network control center manager, FOIA officer, records manager, knowledge management kind of. Yeah, I'm very broad, and I've used these tools, but it's very likely some of you are ahead of me in all of them, and I'll just be your guide through the topics as we move through the schedule. I think I made a minor change. Yeah, I don't think I'm going to hit Power BI and those sort of reports and desktops until after the holidays. But we'll go through a few weeks of foundations and Excel and relational database. I try to hit Python almost every week so that we don't ever quite go completely cold on it. Although when we're in the heart of SQL, I may not cover any Python. So no class on Thanksgiving, the Thanksgiving weekend. We'll come back for a couple of weeks, and then we will break for the 2 weeks of the holidays, and then come back and hit Python hard, particularly moving from traditional structured programming problem solving and moving into the analytical libraries. I have found it works really well. I hope you enjoy. If you've not programmed before, I think it'll be a really interesting journey into computer programming. And I use Jupyter notebooks. They're a web page on your desktop that integrates documentation and coding and active. You can write little computer programs on that web page in your browser. It's a pretty friendly environment now. I'll go through that and make sure everybody's okay. And then I try and weave in some advanced topics, like maybe NoSQL databases, data mining, machine learning, those sort of things. Just as an awareness of what's out there, not enough to give anybody enough information to really apply it, because those are in some cases really bleeding edge technologies. And then we'll move into your cumulative project, which will be all about your work. Can somebody give me a comm check? How am I sounding?
Oh, you're kind of cutting in now.
Yeah, this is frustrating. I apologize. I'm not sure what is going on. And then, yeah, your cumulative project will be work related. So never too early to start thinking about what you might want to do with that. Software for the course is the Canvas LMS. You should have received an email that from Canvas saying, start your free account, and the institution is free for teacher. So I can't change the institution. So that's what you get. If you accept that, create your account, you'll be brought into the classroom, which I'll show you here in a little bit, where we store files and assignments and whatnot. Of course, we'll be using Excel, Microsoft Office, and probably PowerPoint. I think you'll probably wind up, but no, not necessarily. using PowerPoint to present your exercises. Python's up to 3.8. I emailed you guys links to the Anaconda distribution. If you have any trouble getting that help desk ticket approved, or any problem getting, especially Python, installed sooner than later, I do hope you'll let me know, because you're not going to be able to run the Jupyter notebooks. They don't run. They don't post as text files. They're a Jupyter notebook file, IPYNB. So you need that installed so that you'll be able to follow along with the Python lessons. And then, yeah, I emailed you guys a link to MySQL Workbench, which is just a desktop application that lets you write SQL queries and interact with the database visually. And finally, we've got the Microsoft Power BI desktop. Is anybody on a Macintosh and unable to get to a PC? Okay, that's good. We had quite a few folks last time um, on Macs, and there is no, the the old Apple Microsoft war. There is no desktop version, no Macintosh version of Power BI. So that's what we use for showing you just an overview of what desktop reports look like, and visualization tool that's a little more powerful than Excel. It's a lot like Excel, as is Tableau, but it gives you a little more screen real estate, lets your users interact with the data a little bit more. Okay, and then we will have exercises. Most days will end with some sort of a hands-on exercise, so that you can get your hands dirty with all of these tools: Excel, Python, SQL. So I'll try to stay within the 8 hours. Some of this stuff may take you a little bit longer than the class session time. But generally speaking, the flow I like to do is, a little bit of instruction in the morning, and then, maybe 11:30, cut you loose, and with an exercise to complete. And if you want to do that at some other time, that's fine. But I want to give you back some of your time, so that I'm not using more than the 8 hours that we've agreed to with your employer, and yeah, so I'm not monopolizing your time. So we'll do small scale exercises, just write a sample query that brings up this or that, write a Python program that does something. So we'll do those sorts of exercises. But then I've got a couple of exercises where I like to put it all together, more or less, and actually create an analysis project where you'll take 5 minutes and show us the results of that project. So it's more of a cumulative exercise for that tool. But then the final assignment is something you'll work on independently with your trainers, supervisor, mentor at work, and that's going to be a cumulative cradle to grave data analysis project, where you come up with the business question, the principal reason for the analysis. You wrangle the data, you decide how you're going to, what measures will you'll want to reflect and then show the result. And that's using whatever tool you would like to use. You can do a lot of this stuff. You can do data visualization and almost like a dashboard or in Python, or you can do it in Excel, or Power BI or Domo or Tableau. So I want you guys to use the tool that you feel is most effective for your final projects. Wanted to make a note about confidentiality. If if someone shares something about their workplace, we we all know where we all work. Just kind of keep that within the class, as we called it, academic freedom in the classroom, and particularly, not repeating what you might have heard. Folks might talk about, maybe processes that perhaps aren't as mature as they might like them to be, or other what could be considered dirty laundry where they work. So just kind of keep that all within the class, um, for all the right reasons. Make sure that you are protecting your company's proprietary information, or organizations, actually. That's proprietary information. And then moving into the next couple of bullets, any sort of sensitivity. And I know, like, Colton, is it you that's in cybersecurity at GSK?
Yeah.
Any sort of cybersecurity, I know we always run into.
Yeah.
Go ahead.
Can you hear me?
I can hear you now. I heard that last.
Yeah, I just said yeah.
Okay. So if you're working around healthcare data, and it's particularly individual people's data or anything else that's sensitive, work with your mentor, think about it, talk about it, of how you can mask that. It won't come up very often, but just in case, just sort of keep those kind of things in mind as you're moving through. And this will be applicable, like, to the final project. You may or may not want to do a project on something that you won't necessarily want to discuss with the class. So just bear those sensitivities in mind. Let's see. My teaching philosophy. Yeah, guys, I don't even profess to be a cutting edge expert in all of this. I'm a journeyman in all of these tools. I rarely remember exactly how to do what I want to do. I just know that you can do it, and I have to look up the syntax for. There's just so many languages circle around, and in my old brain, I rarely can remember the exact syntax, because you can do the exact same thing in SQL and in Python and in Excel, and then there's a slightly different expression language in. This is killing me. How long ago did I drop? Can you hear me at all? Anybody?
I don't know if you have a way to hardwire to your modem or not, but that might fix, or at least eliminate the Wi-Fi.
Could be. I'm pulling up a different Wi-Fi connection. No, I'm not. Yeah, I can't. Let me think. I do. Yeah, I do. I have a laptop, but I would be out in my living room. Am I still cutting in and out?
You seem fine for the moment.
For the moment. This is frustrating. Okay, I'll have to think about this. Anyway, guys, I don't profess to be an expert in all of this, so please jump in and please feel free to share what you know about these tools. Some of you have been to advanced training. I know he's not here today, but Wesley, we sent him to advanced Power BI training yesterday and today. So he'll be joining us for the rest of the class. I intend to lean on him for what he learned with Power BI. In my experience, a collaborative group of classmates can contribute as much to each other as the curriculum itself. So please feel free to participate whenever you get the chance. I learn by teaching. This is doing these college courses and training courses for something that I'm not necessarily a daily user, forces me into learning it for myself. So I find it really rewarding. And if I don't know the question, I will often Google it right there in front of you. But if I don't know the answer to something that is a topic that you're really interested in, or a question that you might have, I'll find it. I'll find the answer. How am I doing? Still clear?
Yep.
Frustrating. Does anybody remember the maximum length of a Cat5 connection? Is it 100 feet?
I think most cables now reach, yeah, between 25 and 100.
I think I may do that. String it right across the living room for these classes. This is unacceptable. Okay, so classroom mechanics. I'll post all the materials in Canvas, and let me show you what Canvas looks like if you haven't gotten in yet. Look for that email. It may be in your spam folder. It may have gotten buried in your inbox, but you'll need to accept an invitation to Canvas. No, that's not it. Okay. Okay, I should be sharing my my browser. Coming up okay?
Yeah.
Okay, now this is my view, not obviously not yours. So you'll what are we talking about? Am I still on for audio? Okay, try it again. Am I okay for audio? Am I back? Check, check. Am I back?
Yes.
Frustrating. Okay, I'm gonna have to go out and I'm gonna get a 100-foot Cat5 cable and solve this riddle. Everybody see that in the chat room? Am I still on?
Yes.
Yeah, I'm gonna go get a cable and
Yeah,
try and
I see it.
knock this. Yeah, there's something going on with my connection. So we'll back in about an hour, guys, and I apologize.
Okay.
All right.
It's a whole different feeling.
Of course, I forgot to resume recording. That's another thing you guys can help me with. Remember, I don't want long recordings with blank space when we're on break. So I try to pause and then I forget. So if I don't record a session and I'm actually covering something, don't be shy. Let me know. And the notes pages of these slides have some links in them, so it couldn't hurt to download those if you want for further reading. But you're at the kind of the top of the pyramid. Data scientists are the folks that are actually developing new models for looking at the data, different approaches to data analytics. But you know, everything in under the sun when it comes to data analysis is in the realm of data science, really. So you see that term thrown around a whole lot. Data engineer is something I've seen creep up in really just the last, I don't know, 5-10 years. And that's generally the person that manages a data warehouse. Sometimes you see them called data warehouse developers, or they're the folks pulling data from these multiple sources and putting it in a consumable format so that your analysts don't have to do that part of the duty. It's just a way to segment the work. But a lot of data engineers do the ETL pipelines: extract, transform, and load, where you pull data out of a database, maybe supplement it with additional data, or do some conversions if it's in a format you don't like or don't need, and then you load that generally to a data warehouse. And your data warehouse is where you actually do your queries and your analysis. You don't do it on the live production systems. ML, machine learning engineer. Those are the guys. Are we? Am I still clear? Loud and clear?
Yep.
Okay,
Yes, sir.
cool. Machine learning is really interesting, and that's another one of these cutting edge. It can be used for analysis. Like there are analytical libraries in Python where you can do linear regression. So you look at the way two variables correlate, and then it will do the math to project that, where if you plug in another value for X, what would be the resulting Y value. But it uses the variability of that data to sort of simulate linear regression like that. But one thing you've all seen that I think is pretty fascinating in machine learning, it could be considered real-time analysis. It could, but to me, it's really more kind of like almost like artificial intelligence, and that's these fraud detectors. If you go out of state and you stick your card in a card reader at a gas station that is far enough away, in short enough time, it starts to trigger indications, and that is done through machine learning, where all these these transactions, these hundreds, thousands, millions of transactions, they all have attributes like the amount, like the type of store it's at, the time since the last transaction. There's all these different attributes of something like a credit card transaction, and then you put a thing called a label out at the end that is either fraud or not fraud. And then you run all of that data through a machine learning algorithm, and it learns what a fraudulent activity looks like through algorithms that look at all those different attributes and whether the label is fraud or not fraud. And there's lots of other spam, not spam, human, not human. There's machine learning for image recognition, but you train the model and it starts to get eerily accurate with predicting based on the data what something is or who somebody is. Data architect is really more of a designer, just like a traditional building architect designs a building but doesn't necessarily build it. A data architect lays out an enterprise-wide map of how the data lines up to make sure that you don't have gaps, duplication, whatnot. Another important person that you'll deal with almost certainly are business analysts or domain experts that are kind of the bridge between the functional area users that don't really know much about IT or analytics or anything, and the analysts, and they'll be the ones helping you or giving you business questions. Boy, I really wish we knew more about customers and what makes a customer drop off, or what makes what makes a patient cancel an appointment, whatever the case may be. Those domain experts are the ones that help interpret and bring meaning and provide the requirements for your analysis. And then a software engineer is a computer programmer purely. So some analytics are done by software engineers, but it's getting to be with the R and Python programming. It's getting to be where analysts need to think like software engineers, and there are particular lessons learned, tricks of the trade, conventions in software engineering that I'll be covering as we go through Python. Like commenting your code is one we'll run into fairly early. Thinking like a software engineer, meaningful variable names. A lot of it's sort of a running joke. The worst software engineers are the smartest data scientists because they know how to code. They're brilliant, but they just want to get it to work. They just want their answer, and they don't necessarily think about the maintainability of that code like a software engineer thinks about the long-term understandability of that code and how that code integrates, and coming back to that code and knowing what it does and why you wrote what you wrote. So anyway, we'll cover some of those sort of factors. And then this is just the coolest Venn diagram of 4 roles in virtually every business. And that's someone who's good at communication, someone who's good at statistics, at programming, and then business acumen, like the actual line of work that you're in, functional area expertise. And in the middle of this, if you can look at that like 4-sided, almost looks like a Star Trek rank medallion. The perfect data scientist is the intersection of these four. But then you can kind of see, I think some of these are pretty cute. Communication skills with none of the other skills are hot air, and communication skills with business, but with no technical skills is that bottommost intersection, the salesperson. So you can kind of see how these turn in. A statistics background with no other knowledge is a data nerd. So, and you've seen it. I'm sure you've seen the most impressive folks that you run into have a good balance of all of these things. They're not the quiet, shy introvert that can't talk to people. Those people, they may be great programmers, but if they can't work with a client or a user to flesh ideas out, it can be a little bit limiting. So try for a balance of all of those things. And then traits of a data scientist. And I say data scientist, but like I said, all of this analytics is in the world of data science. Math, tech, and business. So as you grow as an analyst, that's the magic triangle that you try and keep in balance. Okay, still doing all right? Sound check, check.
Gotcha.
Yep.
Well, okay. All right. Then you can't have anything in life without a process or a framework or or a life cycle. So I know one of you said you were a Scrum Master. Was that Regina?
That was me. Sorry
Okay.
about that.
Yeah, I know. I call you out. Now I'm on mute. Hang on a second. Yeah, so it's just like, agile processes sort of, compensate for the cumbersome nature of the waterfall traditional, software development, system development life cycle. So you try and get inside that spiral a little faster, or and not try and eat the whole elephant, but do things a little more iteratively and build a little, field a little. Well, there's a life cycle for analytics, and this is certainly not the only one, but it's pretty accurate. I've seen some that use 5 bubbles, 5 stages, which combine the third and fourth one here. They combine data cleaning and data enhancement. But so the main thing though is to start off with an objective. I do hear sometimes non-technical, non-analytical managers just saying, I wonder what this data says. We've got all this data in these systems, for the last 3, 4, or 5 years, whatever. What can we do with that data? Well, that's important, to recognize that you have data that can be potentially mined, but you kind of start, asking burning questions. And this life cycle can be used for one-off questions, like, maybe the board of directors has a wild idea about something, I don't know, an acquisition or a merger, or some new technology that somebody on the board heard about, or a concern that came up in a study they read or whatever. So they want to do a one-time data analytics project. Well, this cycle can pertain to that, but it can also pertain to, like, y'all that are working in a monthly repeating working group, where you come up with new metrics, could be key performance indicators, for the business itself, your basic monthly business reporting of finances, money coming in, money going out, any supplier issues, any quality issues. Your HR folks will likely feed some information into that: number of vacancies, projected retirements, salary, budget limits, those sort of things. So you can use this cycle to refine those sort of routine, repeated metrics, or a one-time thing. So what I'm kind of hoping is that at the end of this course, of course, you guys are going to be involved in this sort of stuff across the spectrum. But for the course, if you could kind of be thinking of something that is a more of a one-time or a first time business problem, a first time that you've looked at a certain set of data and asked a certain question and maybe shedded some light on that question. Not mandatory, but I think it makes it a little more exciting if you guys are working on something that's new versus just learning how to modify the monthly report that already exists. So, and I'm absolutely happy to help you guys work on that. In fact, you'll see, beg your pardon, you'll see in the class schedule here in a couple of months, I would like to meet one-on-one with you and whoever is functioning as your mentor. And that can, if you guys want to team up on a final project within your organization, you are welcome to, or you can do something individual. It's kind of up to you and your supervisors and everything as to how you want to go about that. So anyway, so all analysis should start with an objective, a business question, a problem you're trying to shed light on. Then you move over into understanding the data, which, depending on what you're doing, may take some time to get to know what's in these different systems. You've got you've got finance and accounting systems, you've got production systems, you've got folks applying and postings in your HR system. If you're analyzing network traffic, oh my goodness, you've got so many devices out there on the network that you could be analyzing log file data from. Some of the data will be easily accessible. Some of it's kind of tough to get to, so you got to sort of understand. You would understand permissions, and some of you may not even have necessarily permissions to get to the data that you need. So understanding that whole landscape of where the data is in your organization is that next step. And then cleaning and transformation. You'll download stuff and it'll have potentially weird escape characters. It could be in Celsius, you need it in Fahrenheit. It could be the full name of a department, but you want to use a 2-digit code. You name it. There's data cleaning, data transformation, sometimes called data wrangling. That's a big part of any analytics project, is getting all of that stuff lined up. And we'll learn how to do that mostly in Excel and then some in Python. Generally, in a relational database management system, generally the data is a little bit cleaner if it's checked well on the way in, but not always. So there's almost always some chores to get this stuff lined up.
Hey, Don, this is Dave.
Go ahead.
I didn't mean to interrupt. I just wanted to make sure that on this life cycle right here, when it said the second bubble where it says understanding the data, that's more pointed towards understanding the source of the data, correct? Is that? not necessarily what the data is telling you yet, but just understanding the source of the data and the different sources that you might be using.
No,
Is
that's a great point, because depending on how you look at it, there's data mining where you just go in and start looking at how these different factors relate to each other, looking for relationships. You could do like a scatter plot matrix. There's machine learning algorithms for data mining that show you trends in the data. So getting to understand the sources of the data and the technical would be one aspect, but no, Dave, that's a good point. Understanding what the data means and making sure you have a good data dictionary, so that if like sometimes there are columns in a spreadsheet from maybe a survey, and the data dictionary is separate. So you'll have a column that's named, like, I don't know, SO1. Well, you've got to understand what was actually asked in the question, so that when you're looking at the results of that survey, you understand what you're looking at. So I would not limit the definition of that in that bubble of the life cycle. You know what I mean? It's literally everything to understand of the underlying data. It's not performing the actual analytics. You know what I mean? It's not actually running the model, or hit and go on a visualization tool or whatever. But it's understanding what data you have, how it relates, where it's at, and then part of that you're feeding over down into that fourth bullet, or the bottom bullet, data enhancement. That could be that as you go through this development process, this thought process, you could very well be missing data that you want to start collecting. That could be that could result in a software change to an application that maybe starts to pull web user data or something like that, or change to a survey. It could be a change to a management information system, where you start getting the operator, the data entry person, to add a field because you need it for analytics. It could be that you go out and get marketing data that's through a paid provider. So that's what data enhancement is expanding that. And then the actual analytics is just what you think. It's running the numbers. And inside of data analytics, you're also deciding exactly what you want to present, what factors play into that business question, before you actually present it. And then this data visualization, I think that bubble should really say more like presenting results, presenting the results of the analytics, because it very often that is when you worry most about the charts that you're putting up there, how readable they are, how accurate and trustworthy they are. There's ways to do charts that are a little misleading. I think I've got a tip sheet on that, or a TED talk about misleading charts. So there's some techniques when it comes to that too. So that's really more data presentation, but it's also very often, as the analyst, you will be presenting the results. So there's an element of data storytelling and just communication presentation skills, I think, that are part of that data visualization. And you'll see some models will have model selection, whether that's going to be correlation or a machine learning model, or within machine learning you've got different algorithms that work better on different data. depending on how it's distributed or whether it's, categorical or continuous. So, but it starts with an objective and moves through gathering the data, analyzing the data, and then presenting the results. I guess that's the bottom line I wanted to get to. Sound good? Am I still on?
Yes, sir, you're still on.
Okay. All right. Thanks. Don't, yeah.
Sorry, it took me a minute to get to the mute
Well,
button.
I know. For Zoom, I'm pretty sure the space bar is unmute if you just want to temporarily say something. Instead of grabbing your mouse and reach down, I think the space bar is unmute.
Yeah, you are right. I just tried it. Thank
There
you.
you go. Sure. Yeah, it's handy. I know there's so many of these doggone video tools. So anyway, that's the an example of an analytics lifecycle. And I would like for you to your final presentation will map to that. I would like you'll present to all of us on February 17th. Your underlying objective, and it very well could be 3 or 4 business questions and each of those could have a couple of underlying more granular questions that you actually can answer with data. There's no one way to approach going about this, but I would like you to cover in your final capstone how you develop the business question with your coworkers, leadership team, whatever the case may be. How you analyze the data, where the data came from, what challenges you ran into in gathering that data and cleaning it. If you had to do anything to grab extra data or simulate extra data, what tool and what methods you used to analyze the data. You could do this in Excel. You could do it in a Jupyter notebook, which I've yet to show you. You could do it in a Power BI or a Tableau desktop report. It's your choice, but this life cycle is something I'll keep coming around to. And then there's a maturity model that these are all important, but they do start to get harder to do as you go from lower left to upper right. And that's not to say that good old what happened descriptive analytics aren't difficult. Sometimes depending on the nature of the data and the systems you're using and how much you can trust the data, and whether you've migrated systems or added data as you went along, and so you have data for some issues or time periods and you don't have it for others, that can still be difficult. Just accurately reporting historical data, but that's your typical baseline analytics is your end of month report, what happened last month, and a lot of managers will be able to look at that data and start to diagnose intuitively as much as anything. But depending on how you've set up your metrics and how your organization does analytics, you can move from lower left to upper right, and figure out why something happened. If you look at all the factors, like if there's a bottleneck in the supply chain, like right now, if you had access to all the data, you might be able to diagnose exactly what's going on with the port of Long Beach in California being stacked up with container ships. The truckers are blaming the longshoremen, and the longshoremen are blaming the ship captains, and I don't know that I don't know what I just got the unstable warning. Am I doing all right?
Yeah, just a couple little bumps there, but I think you're back.
Okay, I'm down to. Oh, this is troubling me. I'm gonna have to look into that PCIe card. Anyway, so yeah, predictive analytics starts to look at, as much as you can, the cycle of things, and what's going to happen. And that's where you start to get to magic. I mean, if predictive analytics were 100%, you wouldn't have stock market crashes, you wouldn't have, so much uncertainty as you do. So that's where you really start getting into, kind of next level stuff, is in the predictive and prescriptive analytics. How can we make it happen? That's a great question. I mean, if you can, whatever it is, how can we make sales increase? Sometimes you can do something simple, like look at the return on investment of an advertising campaign. And it's kind of a no-brainer when you go to your leadership to advocate for more money for this or that, because you have historical data that shows that whenever we do X, we get a bump in Y. So, I'm sure your leadership is asking these sort of questions, and then it comes down to the analysis team to figure out how to feed the decision quality data to the management, so that they can at least move as much intuition out of it as possible. But that's the dream of getting from descriptive up to prescriptive, regardless of the type of company or organization. And then just some terms I wanted to throw out there that you may have seen. And I've thrown a bunch of stuff in the speaker notes as well. Like I said, data science gets overused, but because it's the most generic. Everything that has anything to do with data analysis now is in the realm of data science, particularly AI, when it is used to analyze data and come up with answers, like IBM Watson and Big Blue and all of those sort of programs you've heard of. But that's kind of the overarching term for everything. Big data is a term that I believe was coined in 2008, and that the original paper described a shift in, they call them the V's, V for victory, like V for velocity, variety, and volume. So you've got huge amounts of data coming at you in all these different formats from all these different devices, to include video and audio, social media posts, web traffic, logs, all this information coming at an organization in real time too. That's the other thing. Everybody's got a computer in their pocket now, so it's not anywhere near as transaction based and business hours and batch processing and all of those good old mainframe ways of looking at things. Yeah, that's getting to be not the case anymore. So that's what big data is. And then you'll see, if you just Google it up, you'll see people have extended those original 3 V's to include concerns like value. You can't store and use and analyze all of that data, so you got to assign value to it, and that can be used to determine whether you want to store something online or offline. If you want to store it at all, how long your disposition is for data, if you're going to delete it after 90 days, whatever the case may be. So I've seen as many as, I think, 9 different V's, because everybody loves a framework. Everybody loves a methodology. So they're going to jump on the bandwagon and extend it. So you've got these big brain PhDs writing journal articles adding a different V that pertains to big data. I'm sure, veracity was another one. You got data coming in, but how trustworthy is that data? So that I know I've seen at least one paper on the 5 V's of big data. Analytics is what we're doing here. That's just taking numbers and turning it into insight. Data mining is more about kind of like going out in the Old West with a pan and prospecting for gold amongst the rocks, amongst the nuggets, to see what you might find in the data, like finding unknown relationships, like I don't know, bad example, the relationship between the weather and coat sales. But that's an obvious relationship. Data mining can help to find relationships that are not so easy to see. And it's not just running a correlation matrix on all of your continuous variables. There's I'll have a colleague, hopefully I can get on his schedule, Mike Ellis. He's a professor at UCA, go Bears. And there's a machine learning algorithm called clustering or cluster analysis, where you start to look at those attributes I was talking about, the different columns of data, and how those things tend to cluster together graphically, and it starts to show kind of some interesting relationships that you might not necessarily have seen before. So that's a whole nother field of study. I mentioned before a data warehouse. If you've got production data, particularly in like an ERP, and you've got, orders coming in and materials and workers punching clocks and assigning their person number to a job, and all this different data, financial data, it can often make a chief information officer nervous if you're trying to run real-time queries against the data, the live data, because you can write software that is a performance hit on the production system. So what folks have gone to in I don't know, the last 20 years or maybe a little more, is a data warehouse that pulls the data that you want to analyze out of those production systems, and potentially summarizes some of it. You may not necessarily want to store everything coming out of every sensor in a factory or something to that effect. You may pick and choose or calculate averages and then just store that stuff in your data warehouse, and then you run your analytics generally against the data warehouse for anything like historical or trend analysis, that sort of stuff. And then BI, business intelligence, that's looking at what's going on in the business. And generally speaking, I know one of you has been a BI developer. You're the person tasked with coming up with the dashboard that shows the different metrics of what's going on in the business, and they can be static, but they can also be relatively real time, to show what's going on in the business and what decisions you may want to make in near real time, as opposed to just waiting to the end of the month for a report. So that a report's kind of static. A dashboard tends to be something that's a little more real time, a little more active and interactive. That's the magic of these things, is your management can just start drilling on bars in a chart, and it'll come up with the summary data. You can hover the mouse over and it shows you the value. There's really interactive software out there now for BI developers. Does that sound? I know one of you has been a BI developer. You want to expound on that? Am I still clear?
I can hear you.
Okay. All right.
Same.
Okay.
So there we go. And that's why they call Microsoft Power BI, because it's made for those business intelligence dashboards that lets you know how everything is going. You just have to decide what your metrics are going to be, and it's an iterative process. It is a piece of software. You are a software developer. You're just not a C programmer or a Java developer. Okay. I think we should go on break for 12 minutes, and then I'm going to yap for another half an hour, and then we'll be done for the day.
Colby, Katie.
Oh, all right. I'm not the only one who uses voices. Okay. Let's come back at a cell phone time, 12 straight up noon. Okay. Check, check, mic check. How am I sounding?
Sounds good.
Okay. So here's another food for thought slideshow. This stuff is coming out of Google. They offer a program they call Google Career Certificates, and they are courses. There's 5 of them offered through Coursera. It's one of those online training providers. You might have seen graduate certificates and all kinds of different, certificate courses that are actually through Coursera. They're a subscription based platform, but that's just the platform. The content from this presentation is from a Google Career Certificate in Data Analysis, and I'm about a third of the way through it. It's very foundational. There's not, I've yet to get to a whole lot of hands-on anything, and I'm a third of the way through the course. But they did have a really good section on business questions and business problems, and types of analytical problems that, generally speaking, are solved with certain types of data and certain types of charts and metrics. So I just wanted to run through this, and then we will break for the day. But I am going to ask you, end of day Thursday, we'll have an exercise where you list some business questions, and please don't lean CAE, folks. Please don't lean too heavily on what Chaz and Andra did last class, unless nothing has changed, in which case that's fine. But hopefully, in the months since that course ended, some new things have popped up for you guys to chew on. But let me run through this, and like I said, I'll get you out of here by 12:30. Okay, so this is I typed this up. So for my working definition of a business problem, can also be referred to as a business question. Sometimes in academic research parlance, it can be a research question, but it's a narrowly defined issue that can be addressed with data, specific data, tools, and analytical techniques. And they can be, as we saw in that last presentation, they can be from descriptive to prescriptive, but the more advanced they get, the more sub questions are involved that you have to answer to get to that prescription. Just like example, what's the average revenue generated in the first year from a new email lead? And that's something I helped a company with during the last class, is what's the value of a new email, the average value. Some of them are useless. A lot of them, you never hear from them again, but some of them generate loyal customers. So they wanted to kind of find out what, what our average return on investment is if we go if we get a new subscriber. And then your usual, end of month reports or end of year reports. What's our most, least, biggest, smallest, most active, least active, name it, product, salesperson, what's our most effective course of instruction, and then what customer attributes relate to highest sales. That's where you start to get a little bit more into what could be data mining, machine learning. Who is our ideal customer? If you're in some sort of maybe e-commerce, if you're Amazon, what attributes, and how do we go get more of those folks? Or so you start to get more and more and more questions, and I've learned is you'll have a round of these with your management, and you'll answer those questions, and it just generates more questions. They're just insatiable. People are just insatiable for information. So there's really no end to it, and that's why it's in a cycle. That's why it's in a life cycle, because you just iterate and build and improve, and some things will drop off. Some things they stop caring about because it doesn't matter anymore, or it didn't relate to as they thought it might to their decisions. And there's only so much information you can consume at any given time. So there's always the chance of that happening. But they had a nice graphic here on types of problems, making predictions. So you can you can sort of look at historical data and give a best guesstimate of what's going to occur in the future. You can, like sales data, past sales data is always a good one. You can always see different bumps based on seasons and other occurrences. Fast food sales go through the roof during a recession. I don't know. I guess people are feeding their pain. And then there's categorizing things, spotting something unusual can be trouble, but it can also be an opportunity. Identifying themes and discovering connections; those are related, and I've got a slide on each one of those. And then finding patterns within the data. So as we said, making predictions. We want to know, for example, I'll let you read the screen there. The best advertising method. So we look at past performance, and we know that can't necessarily guarantee past performance doesn't guarantee future results. But it's a pretty good indicator, and that's, generally speaking, that's really all you have, unless you're going to do some new innovative experiment, which is absolutely. But you're not really making a prediction. You're making a guess. You have a hypothesis, and then you're testing it. Categorizing things. So you might want to look at categorizing the satisfaction level of customers based on, like this one says, a certain customer service rep might get consistently higher ratings, and then you can look into why that is. Maybe go gather some qualitative data from that rep to see what they do differently than other folks do. I don't know if CAE, do you guys rate instructor pilots or actual class instructors, or is it more about the curriculum itself?
No, for us at this site, it's more about the curriculum and the courseware. The individual program, whatever platform, the ATS, the training school itself, would be the ones that rate the actual instructor and students. Now,
Okay.
we gather data on that. We do gather data based on surveys and some customer inputs, and we provide that data to the program manager and the directors so that they can see how the health of their program, if you will.
Yeah. Okay. I'm remembering that now. You guys provide data, but you don't necessarily you act on it. That's your program management, right?
Right, not at this point, but we are getting to that. That's the whole reason that we created this dog as a dedicated full-time analytics group so that we can start looking at internal stuff within our own process and start acting on our own data.
Okay. There you go. So yeah, categorizing and then spotting something unusual. When you plot your data, especially, you can see outliers. One of these things is not like the other, and that can lead you to look at whether that outlier is a problem, whether it's bad data, or whether it's an opportunity. It may be that somebody is, a statistical anomaly, but you want to figure out why they're an outlier, and get that sorted out. In this example here, a company sells smartwatches, interested in designing their software to spot something unusual in like someone's health. So you work with a functional area expert. I'm sure this company would be working with practitioners to define what something anomalous is, but then also using using that internal software to, like, in that Fitbit that'll ask you appear to have fallen. Are you okay? Should I call the police? So if something happens, or a spike, but to me, from a business standpoint, where you see this is that you'll see the occasional outlier, and it can often be an opportunity, a superior performer. So you want to go find out why that is. But then, outliers mess with your averages. So it's definitely something you want to be aware of. And then identifying themes within the data. Got a long example here. How do user beliefs and practices are examples of themes, but a theme, as it says in this bottom paragraph here, a theme is kind of like a group of categories. So yeah, it's more like a broad group of categories, where my only experience with themes, no kidding, as part of being the research methodology, is in qualitative data analysis. Like you would comb through survey data or customer survey responses or social media posts, and you start to look for themes in the data, like using synonyms. Like you may have or an employee climate survey. They may say that they don't trust leadership. Somebody else may say they don't trust management. Somebody else say they don't trust higher ups. Well, those are all the same theme. So you would group those together, and it's thematic analysis. And then discovering connections between the data. Here we got a third-party logistics company working with another company to get shipments delivered to customers on time. That's a type of analysis where you would discover connections. So this is what brought to mind the port analysis, analyzing the waiting times at shipping hubs. Analysts can determine the appropriate schedule changes to increase the number of on-time deliveries. You could have, finding bottlenecks, things like that. There could be a connection of canceled orders and prices on a website. There's any number of things that can work like this. These are just ways to look at problems and trying to bin them, but don't by no stretch is this a definitive definition or some sort of industry definition. Finding patterns. This reminded me, I was talking to a guy in South Arkansas that was a operations manager at a chemical plant, and he had, I want to say it was several hundred sensors that were gathering data in different formats and at different times, time intervals. And he really wanted to know, because a maintenance shutdown of that plant costs a lot of money. So he wanted to know if there was anyone at this conference that could help him with that sort of predictive analytics of, if what events going on in that can cause trouble, predict a failure. And this particular example is, finding something that had been delayed maintenance results in a failure if it's more than 15 days. So you can look at the failure and look at the last maintenance cycle. Just an example. Finding connections, patterns in the data. And then a key takeaway. And I modified the language on this a little bit because it was saying as you go through the Google program, but as you gain experience within your organization, you'll see these problems, and you almost can't help but start doing that, functional decomposition, root cause analysis, and start thinking about what data would really shed light on this. I was talking to a guy I was coming back from Orlando on Sunday. My mom still lives down there. Fellow was a chief radiologist at St. Vincent's, and he was talking about diagnostic imagery, and the expense of using a more expensive diagnostic image when you already have the data in something like a CT scan that could be reused. Why do a CT scan? So he really wanted to get into that, and just so happens I work for ACDS. Anyway, I thought it was an interesting example of a business question. How can we reuse data that already exists to supplement diagnoses and avoid unnecessary additional cost? But then, as a potential patient, none of us want anybody to be worried about cost, but it's a necessary evil. Okay, and then there's a graphic on and a mnemonic on smart questions, and I'm like, okay, well, that's cute. There are no dumb questions, but this just gives you a small framework from our good friends at Google on asking business questions. And you've got the
Hey, Dawn.
Did you hear
I don't
that?
think we're able to hear you right now.
How about now?
Yeah, I hear you, and I heard your Google Home.
You hear that?
Meeting.
Yeah, I said the magic word and my phone started listening. Man, that is scary. That is so scary. So anyway, these are some food for thought. If you would, as you develop your business questions that you'd like to tackle at work, so that you're thinking through this with your mentorship, your mentor, your supervisors, and I'm seeing the types of domain questions that you guys are looking at, so that I can shape my thoughts as we move towards the final project. So it needs to be specific. It needs to be answerable. And does it address a root problem? There's a lot of things you could ask, but generally speaking, there will be a prioritization of what's, what are the burning issues. Measurable. That's the other thing. Is it something that is measurable? And if you may not have the data for it, but that's a factor that you want, that it is actually measurable by some method. Is it action oriented? And this slide really speaks more to to your leadership than it does to a specific an analyst in the trenches working with these individual tools. But it's good food for thought when you're in that meeting and your non-technical leadership is telling you what their burning issues are. You can start kind of translating that sort of stuff into these business questions. And generally speaking, any kind of a business analyst or a requirements analyst, it's iterative. You got to keep peeling the onion and getting down to specific things that can be addressed. And then, of course, a good question is relevant to what your business need is. And then they say time bound. I thought that was interesting. And it's sort of true, because generally speaking, if you could ask a question that goes back to the beginning of time, the beginning of the data that you have on hand, and that unbounded time limit may or may not be actionable, you know what I mean? Because it's old data. So you may want to say, in the last quarter, what was the largest cause of returns to our e-commerce website, say, when people filled out a return authorization. Those sort of, you can, and the action is to address those products that have a heavy return likelihood, say. So this is just food for thought on what sort of things you guys are going to be analyzing. What are you working on? What does your leadership want you to know, or what do they want you to tell them from the data? So kind of be that bridge between the leadership, unless you're Regina, who is the leadership, asking these questions. And we'll have we'll take the last hour on Thursday to complete this independently. We'll go off Zoom and you guys can work on it. And I'd like to see those before we convene on Tuesday, so that I can take a look at everything Tuesday of next week. So would anyone like to give me an example or two? Is this spurring thought? Are you going to make me pick someone?
Well, one of the things, Don, that my boss always asks me or wants me to look into with the dog, it has to do with efficiency across programs. What's the level of effort for each individual type of product that will turn out?
Okay. Good example.
Another one that I can think of from an auditing standpoint, as a QA person and an auditor, I feel like it'd be pretty valuable to figure out what clauses in the AS9100 standard, what clauses are responsible for the most non-conformances within the last 12 months.
Okay, I don't know what the clause in an AS900 is.
Yeah. So we're our quality management system is certified to a certain standard and space, and we get audited, and you get non-conformances if you're not conforming to the standard, and it's all based on clauses. The organization shall. The organization shall. And so when we get audited, if there's a nonconformance, I think it would be valuable for the organization to know. I think that it would set a trend, or it could give you an indication of trends. What clause is responsible for the most nonconformances in a specific time period.
Okay, yeah, cool, good example. And then you could get into the why, the what is the first question, and then why is that happening? Might
Right,
be
whether it's a training thing, whether it's a resource thing. Yeah, that's what I think.
sure, good example. Yeah, just ACDS is really young. We just started a couple of years ago, and we're just now getting to where we are getting overwhelmed with data, the number of apprentices, the funding source for the training, how many apprentices do we have with which company. We're just now having to worry about dirty data in our customer resource management system. It's called HubSpot. It's like Salesforce, and yeah, we're just now getting to where the state government's asking us, well, how much money have you, how much financial good have you done to which companies? What's the average cost per apprentice? Those sorts of things. So we're now having to produce analytics really for the first time in our existence, which is kind of interesting. Okay, so that's the principle of what I'm getting is, why are you doing the analysis that you're doing? So like I said, we'll work on that on Thursday. I did want to at least pop open a Jupyter notebook on Thursday. Let me stop share. Can you, if you're having trouble getting Anaconda installed, can you let me know? Or I don't know if I want to do this by elimination, which direction. If you've got it installed, give me a thumbs up in the in the reactions. Anaconda Python. I see 3 thumbs. Okay, if you could please get that installed by Thursday, I really would like for you to be able to follow along in your own browser, and to be able, there's a couple of code cells where I want you to type in some commands and get the actual result. If for whatever reason you are having trouble, please shoot me an email. Let me know what's going on. Thanks, Dave. Let me know what's going on. Most of you, I think, are in an organization where you have to do a trouble ticket. Colton, you're with GSK, right?
That is correct.
Have you put in your ticket?
So we talked about it. I talked about it with my manager, and I'm just going to use my personal laptop.
Okay.
Yeah.
Good to go. That's the easiest solution when you've got configuration management issues at work. Great. Jim, thumbs up. Okay, so we'll go over that, and a little bit more. We'll start talking about data itself at the lowest tactical level, and a little bit about statistics and whatnot this Thursday. And then, like I said, we'll take that last hour to write up some analytics questions, things you want to know, and then I may bug you to put a finer point on it, or I may ask you where the data is coming from. I haven't written it up yet. I want to do it a little different than I did the last time. But I'll have some good instructions on there, so you know exactly what I'm looking for. I try not to be, I've been a college professor for 15 years. I try not to be a college professor for these courses, because y'all aren't college students, and we're all We're all professors here. We're not going for credit or anything. All that matters is that you guys learn some good stuff that's useful at work. But I have learned as a trainer and instructor some things that work better than others over the years. So I'll try not to weigh you down too much with academic exercises. Okay, any questions before we break and reconvene on Thursday? Leela, I saw your mic come off mute.
Yeah, I was just gonna say, for me, you cut out right when you were about to tell us what you've learned, just a few seconds back.
Okay, what I have learned, I don't even remember where my train of thought was going. Can you remind me where I was going with that?
A professor.
Oh, yeah. To mix things up, lots of hands-on, not a whole lot of academic exercises. So this business question thing will be some of the only writing I will ask you to do, and it's not lengthy. You know what I mean? Try and keep stuff fun and hands-on. Does anybody need a re-invitation while you have me online here? A re-invitation to Canvas? Everybody good to go? Yes, everybody's good to go except Wesley, and he's in training today. Awesome. Okay, guys. I apologize for the technical issues, and I'll try and get them resolved by Thursday. So I'll see everybody back at 8:30 Thursday morning.
Thanks a lot. Y'all have a good evening.
Yeah,
Thank you.
thanks.
Sure. Thank you.
Have a good one.